I see one answer. Excellent. Any other thoughts on this? Yep, I'm seeing several answers. Fabulous. So this exponent is going to be 36 over 6. And then I can simplify 36 over 6 to x to the 6th power. Fabulous. Okay, that's it. So we've simplified the 6th root of x to the 36th to become x to the 6th power. So that's much nicer. Now, part C down here, we're going the other direction because this 3/5 power, and I know the directions are very similar. Most of these are going to say either simplify, and then your answers will look like radicals or they'll look like exponents. I will try to say on the test, write this in radical form or write this in exponent form so that you know which one you're going to. Because 3/5 we can't simplify like we do 36/6, but we can take this and turn it back into radical form. So what goes as my root? What's going to go right here? Which one of those two numbers? Y'all help me out. What's going to go as my root? Okay. Think back to my root P over R. Yep, I'm getting several correct answers. This is my 5th root, and so that means this must be x to the 3rd power. That's it. That's all I need to do, okay? So I'm just putting it from one form to the other. Like I said, sometimes, and you'll see this as we move through these, sometimes it's easier to simplify if I have a radical, and sometimes it's easier to simplify if I can write it as an exponent, okay? All right. So x to the 1/2 power. How can I write x to the 1/2 power as a radical? It's a very common radical. In other words, what's going to go as my root? Close. 2 is going to go as my root. And so then I'm going to have x to the 1st power, but I don't ever write x to the 1st power. In fact, I don't write the 2 here because this is better known as my square root, okay? So sometimes we get the x squared and the square roots backwards and confused, but this one is my square root. So if you were actually going to type this to me, you could say it is the square root of x. All right, because that little notation is kind of hard to type, okay? But this is the only time when we don't typically write that root number out is when it's a square root. If it's anything other than a 2, we put that root in there. But for this square root, that it is understood to be a 2. Okay, so if you see that radical without any kind of number up there, it's understood to be a 2, a square root. All right, so now we look at this 216 to the 1/3 power. And the 1/3 power exponents are telling us how many times to multiply something by itself, okay? So if I ask you to simplify 3 to the 2nd power, this would be 3 times 3, and you could all tell me that it was 9, right? Well, I don't know how to multiply something by itself a 3rd number of times, and so that's when the exponent doesn't really make any sense whatsoever. So that's when I really need to make sure, because now I've got numbers involved here, that's when I need to make sure and rewrite it back in this radical notation. But because I'm raising this to the 1/3 power, what kind of root do I have? So what number goes in here for my root? Yep. Got one right answer. I got another right answer. Got more right answers. I'm loving right answers. So this is going to be my cubed root of 216 to the 1st power. I'm not going to write that down. Now, the cubed root of 216 is actually a pretty nice number. So I'm going to show you how to simplify this, and then we're going to look at some messier ones. This one you can actually probably do in your calculator. So if you have a calculator that simplifies, this kind of, this kind of calculator will simplify a cubed root if you know how to put the cubed root in. You might can see that lovely little calculator. It's an amazing calculator. But just in case not, this is one of these that we're going to take 216. I would probably on this one, I mean, there's lots of ways you can do this, but 216 divides by some lovely numbers, but it divides by 6. And it's 6 times 36, and then 36 is 6 times 6. And notice these are not prime numbers, but I have gotten to the end of my factor trees, and we're going to talk more about factor trees in just a second. But I've gotten to the end where I have 3 of a kind, and I don't have anything else. And so 3 of a kind tells me that 6 to the third power is 216. And so my cubed root is saying, what did I cube to get 216? So the cubed root of 216 is a 6. And that's it. If your calculator, like I said, if your calculator will do that, there's nothing wrong with using your calculator for that. Some of these cubed roots and fourth roots and fifth roots are a little bit hard. I try not to give you anything really strange and weird, but you can try, if your calculator won't do cubed roots, you can just take numbers and multiply it by itself 3 times until you get this number. If you're struggling with that, let me know, and we can certainly set up kind of a session where I can just work with you on your calculator. But some of your calculators will have an X root. That's what this one has. If you happen to have this calculator in particular, it is this little caret button, and then it says the X root. So anyway, all right, just FYI. Okay, so let's talk about how to simplify those that are not maybe quite so nice. So I love this step-by-step process, and it's very, very helpful. I think it's helpful. I use it all the time. And it's got to do with factor trees. And you may not have seen factor trees since, I don't know, elementary school. Who knows? So that's one of those things that for some of us, elementary school was longer ago than for some of you, but that's another story. I do remember elementary school. So to find factor trees, we're going to factor whatever our number is that's underneath our radical until we have what's called prime factorization. Prime factorization means at the end of my trees, at the end of my branches, I have nothing but prime numbers. 2, 3, 5, 7, 11. Those are prime numbers, okay? And then we're going to rewrite this so that we can pull things out. And so I'm going to walk through these steps for you, okay? So I just like this, and so you can write that down or take a screenshot or print it off or whatever. So we're going to walk through these. So I like walking through them too. So here we're going to start with 90, okay? 90 is not a perfect square, and it's a square root. So we're going to be looking for pairs of numbers. So we're going to start by taking 90 and using a factor tree to factor 90. Now I'm going to do this one with you, and then you're going to help me on the next one. So 90 is 9 times 10. Any number that ends in a 0 has a factor of 10. That's lovely. 9 is not a prime number, and so I can factor it into 3 times 3. Those are prime numbers. 10 factors into 2 times 5. Those are prime numbers. So if I were to take 3 times 3 times 2 times 5, that would give me 90, okay? So I've written 90 now as a product of primes. Here's what we need to do. Because we're talking about a square root, I am going to look for pairs. Well, I have 2 3s, okay? And then I have this 2 times 5 that's left, and they don't have pairs. So how I simplify this is to say, okay, what I have pairs of comes out in front of my radical, 3. And then I'm going to be left with the square root of 2 times 5, which is 10. And so this is my final answer, okay? So I look for pairs because I'm talking about a square root. We're going to do a cubed root in just a minute. Looking for pairs because I'm talking about a square root. And then anything that's left over that doesn't have a pair in it, it's going to be multiplied together. It's going to stay under my radical. Okay? All right. Questions about this one? Okay. So let's look at the square root of 75. Again, not a perfect square. So I am going to factor 75. Somebody tell me two numbers that multiply together to give me 75. I don't care what two numbers, as long as they multiply together to give me 75. Just two. Let me get some numbers going in the chat. Pull out that handy dandy calculator. Think of this as 75 cents. Mm-hmm. As soon as I said 75 cents, I started to get, oh, yeah, oh, I like that one too. Ooh, yeah. Okay, so I really like the first one that came up, but I'm going to use the next like 5 that came up because you all did an amazing job and you did exactly what I wanted you to do. So 5 times, not 5, yes, 5 times 15 gives me 75, okay? So there's another pair of factors too. So somebody else had 3 and 25, and that was great. I love 3 and 25, but most of you came up with 5 and 15, which is really good. So 15, 5 is prime. 15 is 5 times 3, right? Okay. 5 and 3 are both prime. So now at the end of the day, I have my product of primes. Watch, look what happens. 3 times 5 times 5, 5 times 5 is 25. So there's my 3 and 25 also. So either way is okay. What do I have 2 of? What do I have 2 of in my list of prime factors? And this one I had 2 3s. What do I have 2 of here? Yep. So I have 2 5s. So 5 is going to come out in front of my radical. And I'm going to be left with the square root of the only thing that's left, which is 3. And that is my final answer. So the square root of 75 is 5 times the square root of 3. If I put 5 times the square root of 3 in the calculator, I would get exactly the same thing as if I put the square root of 75 on the calculator. The problem is that the square root of 75 is what we call an irrational number. It is this decimal, which is an amazing decimal, but it never ever ends. It just goes on forever and ever and ever. Okay. Now, if you're just doing something to approximate something, you can get the decimal approximation. But if you want an exact value, you really need to leave it in that square root form. Okay, so what's different between A and B and then C? Well, what's different is this is a cubed root. So rather than looking for pairs of numbers, I'm going to be looking for 3 of a kind, okay? So I'm still going to take 16 and I'm still going to factor it. Now 16 is an even number, and so I know 2 divides into every even number. Just kind of like I knew that if something ended in a 5, then 5 divides into it. And when something ends in a 0, 10 divides into it, okay? So that's always very a helpful thing to know. 2 is a prime number, 8 is not. 8 factors into 4 times 2. 2 is a prime number, 4 is not. 4 factors into 2 times 2, okay? So again, I'm looking for 3 of a kind. What do I have 3 of? Well, the only thing I got is 2s, right? Okay, so that was kind of easy to figure out. It doesn't matter which 3 of my 2s I like to circle them up because it just helps me keep straight what's left. So 1, 2 is going to come out in front. 2 times the cubed root. Don't forget the cube here if you're typing in an answer. The only thing that's left is one of these 2's. So 2 times the cubed root of 2 is my simplified version of the cubed root of 16. Questions? Okay. All right. So now we're going to toss some variables into the mix. Now I'm going to tell you a couple of things about this that hopefully will help you to simplify this. One is that I'm going to split this into 3 different pieces. I can split this square root over 3 different pieces, okay? And so that's what I'm going to do to start with. So I'm going to start with the square root of 16 and then the square root of x to the 7th and the square root of y to the fourth. Okay, that's the first thing I'm going to do. Now, I know what the square root of 16 is. Oh, thankfully, the square root of 16 is 4. So we're done with that. So let's talk about x to the 7th. Okay, so this means I've got 7 of these, right? So this is x times x times x times x times x times x times x. That's 7 of them, right? Okay, I know it took just a second to write that out, but you got this. I need to circle up pairs of these because I'm talking about a square root. So I have 1 pair, 2 pairs, 3 pairs. This is going to become x to the 3rd times the square root of x, because that's what's left, okay? All right, so this square root of x to the 7th is going to become x to the 3rd times the square root of x. We're going to clean this up in a minute. This is very messy looking. So now we're going to do the same thing with this y to the 4th. So y to the 4th is y times y times y times y. And I need to look for 2's of them because I'm talking about a square root. Well, I have 2 pairs of y's, so y to the 2nd, and I have no y's left. So there's nothing left under my radical, right? So this y, the square root of y to the 4th, is going to become y squared. Okay? And now I probably would write your final answer like this. 4x to the 3rd, y to the 2nd, times the square root of x. And that is going to be your final answer. So everything that's not under the radical goes in front. Anything under the radical stays underneath there. Question. We just put a bunch of things together. And there's several ways you can go about simplifying variables under the radical. I personally think this is the easiest way. So if you're looking at this from a standpoint of, oh my gosh, I don't remember how to do this at all, I think this is the easiest way to do it. You remember another way? That's great also. Okay. Questions? Okay. So let's try part E here. Same thing, we're going to split this into 3 different radicals. Square root of 32, square root of a to the 6th, square root of b to the 5th. Okay? So let's start with 32. So 32 is not a perfect square. It factors into 2 times 16. 16 factors into 2 times 8. 8 factors into 2 times 4. 4 factors into 2 times 2. Remember, I am looking for pairs, right? And so I have 1 pair of 2's and a second pair of 2's and a 2 left over. So I'm going to stop a second and I want y'all to tell me what comes out in front of my square root of 2 is what I'm left with. What number is in front of my square root of 2? Getting a couple of answers that are not quite right. Yeah, actually, I like that. I like that answer. Okay, so I'm going to pause for a second and ask you to go back up here and remember here, I had 1 pair of x's, 2 pairs of x's, 3 pairs of x's, that was going to be x times x times x, or x to the third power. So this is actually 2 times 2, which is actually 4, and then my square root of 2. All right. So 2 times 2, I like the way somebody wrote that one. That one's good. Is going to give me 4, 2 to the second power, however you want to think about it. But it's more than just 1, 2, because I've got 2 pairs of 2s. Okay. All right, excellent. So now let's look at a to the 6th, and that's going to be a times a times a times a times a. And some of you are going to start to recognize that maybe I could do this like a little bit faster, and you probably can, and there's nothing wrong with that. So I've got 1, 2, 3 pairs of a's, and so this is going to be a to the third power. Okay. And then now let's do our b to the 5th. And that's going to be b times b times b times b times b. And again, I'm looking at pairs because I'm talking about a square root. And I'm going to have b to the 2nd. And then I'm still left with the square root of b to the 1st. Okay. I'm going to stop a second, make sure we're all in the same place. Before I haven't cleaned this up yet. I can still clean it up. Okay. So when I clean this up, I have 2 times 2, which is 4, a to the 3rd, b to the 2nd, and then I'm going to have at the end, I'm going to have the square root of 2b, because the 2 and the b were still under my radical. Questions, 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 questions. All right. So notice this next one, part F here, has a cubed root. Okay. So for the cubed root, we're going to be looking for 3 of a kind. All right. So when we simplify this, we're going to be looking for 3s of these things. All right. So again, I can split this into the cubed root of 24, the cubed root of x to the 12th, and the cubed root of y to the 11th. Okay. All right. I'm going to give you all a minute and see what you can do with the cubed root of 24. And we're going to factor 24. See what you can come up with. If you don't have your chat on, you probably ought to turn it on so that you can see things that are going on. Sometimes I send y'all messages just to see if you're awake. All right, when somebody gets a way to simplify the cubed root of 24, and you don't have to type, you can tell me what goes out in front of the cubed root. That might be easier to type into the chat. Tell me what goes out in front of my cube root. Because something's going to go out in front and something's going to be left underneath. Yes. And I'm going to give y'all about 30 more seconds to see if anybody else can come up with an answer and what goes out in front. Remember, I'm looking for a 3 of a kind. Okay. Somebody. No, you're just answering it. People are just sending me private answers. That's okay. Somebody answered the whole stinking thing. Stop. Anyway, okay. So now we've got, yeah. Some of y'all are just like 5 steps ahead of me. So the first thing I've got is I've got 3 2s. So this cubed root of 24 simplifies to 2 times the cubed root of 3, because 3 is what I'm left with. Okay, I had 3 2s, and so the 2 comes out in front. Okay, for those of you who are 5 steps ahead of me. So x to the 12th. Now, I could write 12 x's out here. Oh my gosh, that would take me forever. Instead, I think I'm going to write x to the third. So this is going to be x to the third times x to the third times x to the third. And I'm going to tell you why I did it this way in just a second. You're going to see that in the next one. Okay. So I know I need 3s of them. So every time I have an x to the third, then that's 3. And so I can bundle that up into 1. Okay. So this is 3x's, 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 and 3x's. And I would just keep doing this until I got 12. So 3, 6, 9, 12. So this, when I simplify this, I'm going to have 3 of these. So there's 1, 2, 3, 4 groups of 3. So this is going to become x to the 4th with nothing left underneath it, nothing left. And I think that'll make a little bit more sense when I do y to the 11th. Again, I'm looking for 3s. So 3, 6, 9. Uh-oh, I can't get 12. I can't get 11. So I need a 2 here. Okay. So this is, and if you need to write this as 3 y's and then 3 more y's and then 3 more y's and then 2 y's, then that's okay. And you're going to see what's happening here. For every 3 of these, I'm going to have 1 that's going to come out in front, right? But I'm left with this underneath. And so this is going to be 3, y to the third, and then I'm left with the cubed root of y squared, right? Yes, you did actually make sense. So I'm going back to look at, yes, I knew exactly what you were talking about. Yeah, you're good. Yes. Sorry, I can't do multitasking. Yes, okay, all right. So now I'm going to clean this up just a tiny bit because I need to make it look a little bit nicer. I got too many pieces out here, so we don't like 500 pieces. And so this is now going to become, so we're going to put all of our parts that are not under a radical. So 2x to the 4th, y to the 3rd, which is what a couple of people told me was on the outside. And then I'm going to be left with the cubed root of 3 y squared, and that is going to be my final answer. Woo, that was messy. Questions? I could ask you if you like this better than the first of chapter 6, but I think everybody would say yes. I think everybody likes anything better than the first of chapter 6. You would probably go to the dentist and get all of your teeth pulled rather than doing the first of chapter 6 again. All right. We good? Lots of parts to this. Just take some patience. All right. So when we talk about negatives, we just have to be careful. If we have what's called an odd root, then we can have a negative underneath it. So if we're talking about the cubed root of a negative number, life is good. If I try to take the square root of a negative number, life is not good. It's not real. It's imaginary, and we don't like those, okay? If the negative's on the outside of the square root, life is fabulous. We just make the answer negative, okay? So this is just kind of a summary, and we're going to go through and look at these problems, all right? So this first one, negative is on the outside of the root. So I don't care what kind of root I have, all right? I can work this problem. We're going to go through each of these and decide, can we work them, can we not? And then we'll go back and work them, okay? So A, we can work it. Negatives on the outside of the root. I don't care what the root is. Life is good. My answer is going to be negative. Part B, I'm asking you to find the cubed root. Cubed root, cube is an odd exponent or an odd radical of a negative number. Excellent, we can do that. Answer is going to be negative. So up here in part A, my answer is going to be negative something. We'll come back to that. In part B, I can do this and my answer is going to be negative. Part C says I want to find the fourth root. 4 is an even number of a negative number. And this is the one that I can't do. So this is not possible. Or another way to say this that we talk about in algebra, in college algebra, is it's not real. Okay? All right? So now we'll go back and simplify these, but this is just making that connection from the previous information that talked about if we have an odd root with a negative underneath, the answer is negative. Even root with a negative underneath, we can't answer it. Negative on the outside, the answer is just going to be negative. Okay? So these three things. So now we need to figure out what the square root of 256 is. And if you, so this is going to be the square root of 256. If you punch that into your calculator, it will actually tell you 16. Okay? Now, if you put the square root of negative 256 in your calculator, it's going to say you can't do it. So don't put the negative in there. Just don't. It just makes life crazy. On this one, you can try that, but your calculator may not do fourth roots. I don't know. Okay? But the square root of 256 is 16 because 16 squared is 256. And because it's a negative in front, my answer is negative 16. All right. So part B, not number 3. Part B here says the cubed root of negative 64. It's going to be a negative answer. We've already talked about that. Does anybody remember what the cubed root of 64 is? And you can punch this into your calculator. It's actually a nice whole number. The cubed root of 64. I got one right answer. 2 right answers. 3 right answers. Make it unanimous. I get a 4th right answer. Yes. The cubed root of 64 is 4. Because 4 to the 3rd power is 64. And since it's a cubed root of a negative number, I get a negative answer. What this means is that negative 4 times negative 4 times negative 4 equals negative 64. And that's what I had underneath that. That's all a cubed root is. It's this really cool little thing. Okay. Let's do. So We just keep making these little guys look worse and worse, but I promise you they're not that bad. So if you have, a while ago we had the square roots and cubed roots of a product of things. And so now we're just talking about what happens if I have the root of a fraction, and I'm just going to break it into two pieces, okay? So this becomes the square root of 25 and the square root of 64. So I'm just looking at these in parts, okay? So the square root of 25, I hope we all know now it's 5. Be careful here. What's the square root, not cubed root, square root of 64? And it's not 4, by the way. Yep. 64 is this really cool, nifty number. It is a perfect square and a perfect cube. I think that's kind of nifty. Let's see if anybody else knows what the square root of 64 is. There we go. Okay, 2 more answers. Okay, so the square root then of 25 over 64 is 5/8. That's it. That's all you got to do. Okay. So this next one's going to be a little bit harder because we got to do a little bit more work, but we're just going to practice simplifying our radicals. This is the square root of 18 over the square root of 49. Now the square root of 49 is pretty nice. It is 7. We love that one. So the square root of 18, we've got to work a little bit on. So the square root of 18, 18 is going to factor into, it's an even number, so 2 times 9. 9 factors into 3 times 3. I'm down to prime numbers. I have 3 of these. I have 2 of these, 2 3s. So the 3 is going to come out in front, and I'm left with the square root of 2. And that, folks, is my final answer. I can't do anything else. I can't simplify anything else. Nothing divides into anything. Questions? Questions. All right. Now we have that 1/2 power, okay? So before we can simplify this, we have to change this into a radical. So we have to put this in its radical notation first, because that 1/2 power, when we're dealing with numbers, is just really messy. And so this is going to become the square root. Doesn't look like a 9. The square root of 9 over 16. And that's going to be the square root of 9 over the square root of 16. And what is the square root of 9 over the square root of 16? Somebody's tell me. Yes. There's one person. I need an answer from everybody on this one. Square root of 9 over square root of 16. I need a response from everybody if you want to be considered present. That response can be, I don't know. You should know this one, but it can be, I don't know. I don't know is acceptable. Yes, yes, yes. Okay, I'm thinking a couple of folks are going to sleep on me. Brandon, Chelsea, Jayla, Aaliyah, Brianna, y'all are out there. Check in, please, please, please. Check in, check in, check in. I need an answer in the chat box. Yeah, hey is not an answer. I need an answer for the problem. I'm going to start marking people absent, absent, absent. Well, not sure what problem you're answering, but okay. Present means focused. All right, I'm going to take it that nobody else is here with us. So we're going to simplify this. So the square root of 9 is 3. Thank you. And the square root of 16 is 4. All right. That's it, 3/4. Beautiful number. Okay, so this next one is harder. Okay. What is different about D? Can somebody tell me what is different about D? It is different. It has one very significant difference. You can think you know it, you can tell it everybody, or you can just tell it to me. I want to see if you can figure out what makes D different, because sometimes figuring out what makes something different is the key to being able to work it. And so it's really easy for me to sit here and tell you what's different, but it's really important that you see what is different. So look carefully. I know there's different. One has a 24/64, one has 9/16. I'm not looking at that. There's something, yes. Put a question mark behind that. Yes. You can state it with, yes. Thank you. State it with emphasis and power that you know. Hey, actually, you're right on that one too, but it's okay. That's different. So, okay. So what I'm looking for is the fact that I have a negative exponent. But somebody said that this was not a perfect square, and you are so correct. So sometimes y'all are just observant in different places than I am. So that's amazing. I love that. That's my favorite part. So, okay. So the thing that I'm really looking at here is the fact that this is a negative exponent. So before I can do anything else to this problem, I have to make that a positive exponent. So that means that I have to flip this over and make this 64/27. And now this is to the positive 4/3 power. Okay. Very first thing is to get rid of the negative exponent by flipping what's underneath there. Okay. That's huge. Okay. Completely different answer. Now we're going to turn this into radical notation. So this is the cubed root of 64/27. And all of this is raised to the 4th power. Now, I'm actually going to do this. It doesn't really matter which way you do this. We can put it in here as to the 4th power. It's going to be messy whichever way we do it. Okay. So now what we want to do is we want to split this into the cubed root of 64 to the 4th power. And I'm actually am going to write this. It's easier if you do the 4th power on the outside. And I'm going to tell you why. Okay. So the cubed root of 27. Right. Now, it's actually a good thing that it wasn't a perfect square, because I didn't want a perfect square, but we didn't know that at the time. Okay. So now, and once again, notice that I pulled that power outside, because that's the last thing I want to do is the power. So in the numerator, I want to find the cubed root of 64. Well, we've done the cubed root of 64, and the cubed root of 64 is 4. So I'm going to have 4 to the 4th power. So I'm going to put this little exponent here in still pink. So 4 to the 4th power. To the 4th power. All right. And then in the denominator, the cubed root of 27 is 3. And that's going to be to the 4th power, okay? And so now I'm going to do 4 to the 4th power. 4 to the 4th power is 256. You can do it in your calculator. 3 to the 4th power is 81, and that is my final answer. Questions? Questions? That one was hard because you've got to flip it, and then you've got to do the cubed roots, and then you've got to raise them to the powers. So you have to make it a positive exponent first, then write it as your radical, take care of your root part first, and then do your exponent last. So if you have both a root and an exponent that you need to simplify, I would always do the root part first and then do the exponent second. Questions? Okay. So the next thing we want to do is talk about working with these radicals. As long as we have the same roots, we can multiply what's underneath. It's kind of the opposite of what we did a while ago, where we broke these things apart. Now we're just putting them back together, and if that helps us to simplify, we do, okay? So in this particular problem, I have 2 square roots. If I had a square root and a cubed root, I could not do this, okay? But because I have 2 square roots, I can simply multiply those numbers together. I just keep my root, and this becomes the square root of 70. That's it. That's my answer. Okay. Now for this next one, we have to be careful with this because I know what the cubed root of 8 is. 8 is actually a perfect cube. Does anybody know what the cubed root of 8 is? What can I raise to the 3rd power and get 8? 2, yay! So this actually becomes 2 times the cubed root of y, okay? Now, if I had, we'll come up with part C over here. If I had, let's say, the cubed root of 11 times the cubed root of y, this would become the cubed root of 11y. So I can do the same thing. As long as I have the same roots, I can multiply together what's underneath. But because I know what the cubed root of 8 is, I would simplify that. If you can simplify roots, simplify them. We love to simplify. Simplify is good. Simplify is simple. Or, okay. All right, so 2 more examples, and then we are done for a Friday morning in June. So same thing here, we're going to keep this radical. So sometimes it's one thing when we've got variables underneath there, but something happens when we start talking about cubed roots and numbers, and we think we need to do something with those roots, but we don't, okay? So just like on this problem, square root times square root becomes square root, cubed root times cubed root becomes cubed root, and I multiply those 2 things together. And that's my final answer, okay? So my answer is, I just keep that cubed root, I'm multiplying. I'm not talking about adding anything else, I'm multiplying, okay? All right. So here on this one, it's very similar to one we did a while ago. We can split this into pieces, and so this becomes the cubed root of 80, the cubed root of x to the 10th, and the cubed root of 27. Now the cubed root of 27 is, to me, the easy part. It is a perfect cube. Does anybody remember what the cubed root of 27 is? It's a lovely number. Yep. It is 3. The cubed root of 80 we have to work on, so we're going to come over here to the side, and we're going to work on this cubed root of 80. So 80 is going to factor into 8 times 10, and 8 is going to factor into 2 times 4, and 4 factors into 2 times 2, and 10 factors into 2 times 5, okay? So I have 3 2s and a 10 left over. So this is going to be 2 times the cubed root of 10. Can't do anything else with that, right? And then remember, when we want to look at this x to the 10th power, however you want to think about this, but x to the 10th power is an x to the 3rd, that's 3 x's, and 3 more x's, and 3 more x's, and then an x to the 1st power. So 3 plus 3 plus 3 plus 1 gives me 10. Or I could literally do all 3 x's, 3 x's, 3 x's. But when I circle these up, I'm going to have one group of 3 x's, another one, and another one. So this is going to be an x to the 3rd power, because I have 3 of those, times the cubed root of x is left. And so then when I simplify this, I have 2x to the 3rd times the cubed root of 10x all over 3. And that one's a little bit messy, but we got this. Questions? Okay. I don't even want to ask this, because so I'm not really going to ask this. I just want to know if you finished your homework. You probably haven't. So now is when I'm going to send you to go forth and be free and finish homework for chapter 6 and take your quiz. And I'll hang around here on WebEx for about 30 more minutes. So if you've got questions, you want to stick around and ask, that's great. If you want to pop back in and ask questions, that's amazing also. So, or if you've got questions about this that you want to stick around and ask, you're welcome to do so. But if you're paying attention and you're with me in body and spirit, then you are free to go. And if you're not, then you're not. So anyway, so that's what I got for you.
Can I ask a question?
Yes, ma'am, you can. What's
Okay.
up?
Can you back up one page?
Yes.
Okay. You added the C in at the bottom.
Yeah, I just added an extra problem.
Right. So between the B and the C, so the C's answer over to the side carried the 11 over, and it's 11y. Why do you not carry over on B the 8 over to the y? Why is that one different?
So because I could have done that. I could have written this as the cubed root of 8y. Okay. And I chose not